welcome to another webinar. So this evening we have with us Kiran GS, who will be giving us some insight on the competencies in industries with the focus on the software industries. So sir, a very good evening to you and welcome. I would like to call upon you to introduce yourself and then proceed with the talk.
Sure then. Thanks, Ashi. My name is Kiran. I am working in Bosch Global Software Technologies. Also, you can call it as BGSW. We come from a, let's say, a software company wherein which we, from a Bosch angle, if you see, Bosch is a conglomerate. It has a base in Germany, but it has a lot of subsidiary companies all around the world. And in India, we have this BGSW. Along with this Indian location, we do have BGSW across other countries, which I'll touch upon. As such, I'm a Bosch certified solution architect, specifically for industrial automation. When I try to say industrial automation, we are talking about this control systems, Industry 4.0, IoT solutions. These kind of portfolios, I kind of try to provide software solutions predominantly, and that would be my most of the work time allocation. Apart from that, I would also focus on this cross collaboration activities within our section, what we call it as multi market. So this is my short introduction. I think this should be fine for now. So can I move ahead?
Yeah, please.
Please do.
Okay. So I'll just touch upon this agenda for this today's topic, the competencies in industries. When we bring in this topic, no, first, of course, I'll give a context of Bosch as a company itself, because at least from an academy point of view, you can see how Bosch as a conglomerate is kind of situated in multidisciplinary, multi-industry, and even multi-geographies in that context. And also we'll bring the context of industry itself, what we really mean by industry. And specifically, I'll also touch upon the software, and or moreover, I'll be focusing on the software predominantly. And of course, some part of the manufacturing industry also I'll touch upon, and how are these interrelated? I'll bring a perspective with. At the same time, specifically the main topic, the competencies in industries, is also quite relevant for the academia. And for sure, I'll be focusing on some relevance itself. When I meant by relevance, I'll try to associate what you actually kind of get the knowledge by reading certain books or something, and how do you apply in industries. I'll try to give some correlation to that, and how do you kind of think from a, if I want to call it as a reference career path, it's one of a way. So in that direction, what your competencies gained during your academia and what competencies are required in industries can be kind of interrelated. Some interrelations I would try to bring in. This would be my agenda. First, to begin with, Bosch as a company, if you see, as I told, it is core in Germany, and what we call it as Robert Bosch GmbH. And specifically in India, we have Bosch group of companies, whether we can call it as Bosch Limited, which is also called as RBI, which focuses more on these kind of starter motors, alternators, pumps, diesel injectors, or even from a automotive segment like this ECUs. Even Rexroth is also a Bosch group company, which focuses on more on these hydraulic components and control systems. Multiple Bosch companies are situated in India. We come from, or rather I come from, Bosch Global Software Technologies, also called as BGSW, specifically focusing on the software segment, catering to all these other Bosch entities. Of course, there are other Bosch subsidiaries, including this Bosch home appliances. But if I try to target or focus on BGSW, we as BGSW provide this industry specific solutions in healthcare, mobility, what we call it as automotive sector, retail, what we call it as consumer sector, and obviously the manufacturing or the industrial sector. These are the industry specific solutions we provide, and we are situated in multiple countries. These are all the international delivery centers like Vietnam, Poland, and Mexico. And of course, we do have other centers for sales, but predominantly other than India, we do have other countries locations. We do provide these kind of solutions like connected products, embedded technologies, enterprise IT, data science, and AI, predominantly in these kind of domains where I try to focus on automotive, healthcare, manufacturing, and high tech, which is more towards this enterprise IT levels and all solutions. And of course, we just completed our 25 years on 2022. We're almost more than 25,000 associates. Yeah. So, to the topic, when we come for context of the industry, there might be a different way of trying to emphasize these things. Some people or some experts try to classify that one as primary, secondary, and tertiary. Some others would try to bring in the perspective of these kind of production, capital, and consumer based industries. I would rather stick into this categorization because it gives much clear distinction. What we meant by this production goods industries are like they actually manufacture the products. The product itself might be a raw material or a final product. Typically, these kind of automotive, like in Bosch areas or in utility sectors or energy sectors, are can be considered as production goods industries. Of course, there can be an industry which can be kind of overlaying with other categories also, but otherwise predominantly these production goods industries are focused more on the products, either as a raw material or a final product. But at the same time, there are other industries called as capital good industries, wherein which they only manufacture the materials. They don't produce the final product or something. The materials can be used in such a way that it can be kind of used by a production goods company or even a consumer goods companies. Basically, those materials can be for a capital investment, which means to say like machineries. You should have imagined that if I want to produce something, I need not rely on my manual human intensive labor. But there has to be some machineries which can be more automated, or even the equipment part other than the machineries. So these kind of machineries development or equipment development are very market specific. And these kind of capital good industries focuses on delivering these machines to these production or consumer goods industries. And specifically the consumer good industries wherein which they actually manufacture the final product. That is, they literally transform the raw material to a final product will be more focused on this kind of B2 C based of uh, industries. So predominantly these food, healthcare, electronics, and appliances are under this kind of segments. Yeah. So basically, if you have seen that Bosch also provides this home appliances. So obviously Bosch do provide this are based on this consumer good industries also. So that's the reason when we try to classify Bosch as conglomerate is it is multi-industry. Yeah. And also obviously it is multi-geography point also is there. But when you try to see this kind of three different kind of industry sectors, there are something like horizontal services or horizontal industry. If I want to classify what we can classify, these can be the software industries and other industries. My focus would be only on the software industry for now. So when we think of the software industries, typically how we work is something like this. When we get a business opportunity, we try to bring some user scenarios to that. We convert those user scenarios to some kind of requirements. We design, we code those, and then we finally test and deliver that final software deliverables. It can be either an embedded software or any kind of software. And finally, we do maintain and dispose over the period of time. During this, it might be possible that we may also try to develop some hardware or at least do some system integration. Typically, this is what software industries would look like. So when I try to kind of give a more detail to this software industries, because from a competency point of view, first we need to be very clear with what we meant by domain technologies and platforms, because typically in a software industry or in general industries, we do kind of mix certain things, like we call a programming language as a technology. So that differentiation should be very clear, that the platforms are the languages, operating systems, the IDEs used, or even the hardware and all can be kind of resource level. These are all the platforms wherein which you can use to develop actually certain technologies. These technologies can be an embedded or real-time, web, desktop, or mobile-based technologies you can use, or even a networking technologies like Bluetooth, TCP/IP, serial communication. And mostly nowadays, we are more focused on this edge and cloud computing. Other than that, we do have this graphics, sensor actuators, data acquisitions, and even the data science. These are all the technology part of industries we can think of. Yeah, and there are many other technologies for sure, but predominantly we can kind of have these kind of technologies. And there are other emerging technologies also, which we'll touch upon. But otherwise, these technologies are what we call it as domain independent, which means it doesn't matter whether I use a Bluetooth technology in which domains. So that is where the domain comes into picture, where in which literally it needs some kind of an engineering from a final, let's say, uh, area of implementation, if I want to say it as. For example, if you see an automotive industry or the domain, which can also call it as mobility sector, it might be very different from the consumer goods or even finance. Specifically, if you see the finance and education are almost like parallels. There is no much interrelation to that. We can bring in some, but otherwise it is different domains by itself. The knowledge gained for a financial sector like banking and all, it might not really be applicable from a technical angle to a manufacturing or an automotive sectors or a domains. Yeah? So that is why we are, we'll classify these kind of domains which are technology independent, which means the example for a simple consumer goods. Let's simply take some kind of power tools. The power tools can have different kind of technologies which can be having implemented with different kinds of platforms. That's how we classify these kind of domains, technology platforms differently in software industries. And moving on, basically, when we try to think from a competency point of view, whether we try to bring the perspective of software industry or even other industries, I would try to bring in some aspect of what's a competency in general look like, and then specific to some manufacturing or purely software engineering industries. First, of course, you could have seen that the manufacturing industries definitely have to focus on the lean manufacturing. Sometimes even smart manufacturing word is used commonly. All these things are interrelated, but at the same time they have to focus more on the health and safety. This how to maintain the safety of the human and also even the machines are also important, and how to ensure that these things can be also quality controlled. These are all the competencies specifically required in manufacturing. Similarly, something are also required in software, but at the same time, the software more focuses on this programming, tools, methods, and even this productivity and efficiency. This is one of the, let's say, the key competencies required from an angle of a business point of view, wherein which sometimes it is quite challenging to balance between the profit and then the maintenance part of the organization itself. That is where we focus heavily on the productivity or efficiency part. The competencies required in these areas is very significant, but at the same time, if you see, there are lot many general competencies which are required in industries. Some of them are like, obviously we need to have a very strong engineering fundamentals, problem solving, communication and cooperation, creativity, innovation, and other competencies over here. Mainly, I'll also touch upon this resilience and the VUCA part later. Basically, from let's say from an engineering student's aspect, at least when I try to interview certain, let's say, candidates, I would look upon mostly these engineering fundamentals, problem solving, communication and cooperation, and then what competencies do you have from a technical angle. That would be the more focus. Then later on, all the decision making, leadership, entrepreneurial and all would be kind of for sure used. And of course, you have to be very resilient in this adapting to this VUCA change. What do we mean by this VUCA changes? Technologies keeps changing nowadays at a rapid rate. That is what we call it as VUCA, where in which it is kind of abbreviated to this volatile, uncertain, complex, and ambiguous situation of the market. These kind of changes, you will have to be a resilient. You can't try to say that, okay, I only need to work on AI systems, being a engineer or a out of university, or you can't say I will only work on something like web technologies, and that too specific in something like one programming languages, like let's say Angular technology. You'll have to be kind of adapting to the other web technologies also. So how do you gain these kind of resilience and be adaptable is also very important. And if I want to try to give a very high level of some info on these kind of skills, if I want to bring in, or even the ability or a knowledge point of view, let's quickly go through some of them very in brief, not much detail. So when we think of the first and most important, let's say a skill required from an industry, and specifically in the software industry, is problem solving. What we meant is, when we get them some kind of a challenge, we don't need to find what's available for that. Yeah, there is always a framework. Yeah, there's a typical framework provided in the let's say industry. But if you want to kind of deduce that, or what does it mean is, we are trying to say that when you get a challenge, try to get the data, which means to say what is the baseline of that. Try to feel what are all those kind of benefits and also the critical part of it, the situation, to find the fact, because there is a problem to be solved. And then you have some kind of problem finding methodology like root cause analysis and 5 wherein which you get to know the bottom what really the problem is about. And then to kind of find a way to how to come out of this thing, we have certain techniques like brainstorming. This is typical what we call it as trying to have a deliberate discussions on how it can be solved. And of course it will be also incorporating some creativity. We do get this creativity involved to have multiple solutions. Now we'll have to find a decision now, which means out of this multiple ideas or solutions, which one would best fit. That would be more focusing on this decision making. And then finally, we will be getting to know what's the way forward. This is a typical framework for any problem solving. Yeah. Likewise, if I want to touch upon the decision making itself, we do have something like a standard method in industry called DAR, or decision alternative result. But at the same time, it can be also called as pug matrix. Yeah, different ways of telling. What does it mean is simply, if put, they try to bring in the perspective of, try to have your alternatives. Here in example, you can say that some solution, do I need to only have a client solution or client and server based solution? So for those two alternatives, you kind of describe your criterias and bring the ranking, which means the weightage for each of them. Which one you think, whether the performance is important, rate it high, or weight it high. And if the tie to market, sorry, the storage is not that much of an importance, give a weightage of low. So in this way, you categorize these kind of rankings and then try to bring all the criteria related to this, and then bring in whether what the decision you made on client or server tries to satisfy this criteria. If it is kind of giving this alternative, is it giving more than expected, try to bring in plus. If it is less, bring in negative, or if it is same as expectation, put it as S. So with this one, you will try to bring a weighted average and try to see, okay, which decision is best fitting. This is one of the simplest tool we used in most of the decision making process. The representation can be different, but typically it could be something like this. Similarly, if I want to bring in some aspect to what is creativity and innovation, we try to think about the creativity as something like divergent process, which means to say it keeps generating an options. Many ideas would come, but the innovation is more like convergent process, which means you need to kind of bring some final selection process. We need to bring a final solution aspect of it. That's where we kind of say innovation more focuses on the user perspective, finally what the user wants. Yeah. And also it is more of a solution focus, whereas the creativity is more on a technology focus, wherein which it brings from a problem aspect, which means it tries to see a problem and try to give some kind of ideas to bring some multiple ideas, and then that would actually be further converted into a solution. That is where the creativity and innovation goes hand in hand. So this is also kind of an important skill to be uh, there in any level of let's say corporate roles, which means whether it is a fresher or even let's say a director of a company should have these kind of different skills. And specifically, when we think of creative innovation, it doesn't mean it has to be always in the bottom line. Then, more importantly, we have this communication and cooperation. Yes, the from an academy point of view, the latest generation is very well accustomed to these kind of communication tools like written and oral influencing and all. But at the same time, there has to be a skill to actively listen and also specific audience, because when I try to now talk about this webinar, the competence in industries, I have to make an point that I am speaking, or rather would be speaking from a perspective of or targeting a university students as an audience, not some other customer who is actually wanting some technical solutions. So which means when you communicate, you have to be a specific audience focus also. And at the same time, you do need to get into a good cooperative mode, which means you need to be a very team spirit, not an individual player. You need to collaborate, wherein which not only within the team, but also inter-team, which means sometimes we do get a situation wherein which a hardware and team and the software team have to work in sync, so that the collaboration is very important. While we do that one, there might be very much a conflict, and you need to have a management system for that. And from that angle, whether you as a project manager or you as a fresher joining a company, we do have to have some kind of conflict managing systems place, so that we come to a some kind of agreed common cause. Yeah. And of course, we need to see that while cooperating, we are addressing multiple diversified audience, whether it is from a gender perspective or even a thought process, mindset point of view. So this kind of communication and cooperation skill is very important. Yeah. And moving on to really the need of an hour is this productivity and efficiency in an industry, wherein which, if I think from a programmer point of view, we are asked practically to not to code much and try to use more of this tools like this GitHub Copilot, which can also auto code generate, also do a test script. I mean, when we do a code, we'll have to test certain applications or any deliverables. Generally, it is not feasible that we keep doing or testing the manual based testing. That is where the automation testing would be more predominant. There, instead of scripting ourselves, we have to make use of these kind of copilot tools which can auto generate the test script also. And obviously the build automations. What do we mean by build automation itself? When we keep changing the code, it should not be kind of we need to keep compiling, building, and then doing all those other testing activities. It has to be automated. These are something which is more often looked upon in a software industries, and specifically from an engineering process. A lot of emphasis is given for this generative AI data science point of view, wherein which as simple as if we get a requirement from our customer, we do have to see whether this kind of requirement is already available in the catalog of our requirement itself, or it is something new. How do we do that one? We traditionally try to see whether this kind of requirement is there or not from our documentation manually. Instead of that one, these kind of generative AI tools are used to see that these kind of things are already there. Or in some other use cases, sometimes you would have seen that from a legacy point of view in a manufacturing area, a lot of mechanical drawings would be lying around from a hard copy. Trying to make that one digitize is a kind of painstaking. These kind of generating AI tools or other tools are used in conjunction to bring this thing in automated fashion. Similarly, from design to efficiency, it's not that we kind of need to code and test and then try to see if there is an issue. While designing a system itself, whether it's a software or a conjunction with the hardware, we'll have to see whether our design itself is efficient enough. And obviously, during this, we have to adapt since we are focusing on this productivity and efficiency. Reusability is a very important topic wherein which we don't want to reinvent the wheel. That is where when I try to give a customer a feel that I can try to do this activity or task not in something like 3 months, but in 1 month. That's a very good value proposition we'll give to the customer or even a partner in that context. So these are all these, let's say, from a soft skill point of view and some towards the productivity and efficiency. When we try to bring from an engineering or a technology aspect itself, yes, this is a common practice everywhere that me as a solution architect will have to follow the technology trends to see what kind of programming language I might have to use, what kind of platforms I might have used, and where I need to focus on the future technologies. But when it comes to academy or university or even a fresher, where it is important is I would give a kind of an advice wherein which it's not from a perspective of what the trend goes on. Yeah, trend is required from an adaptability point of view, but I would kind of give some suggestion from a passion also, wherein which being an engineer, you might be passionate about certain technologies. So you start with that one because it is easy for you to learn and quickly grasp onto that and then kind of give some value add in the actual industry where you belong to. Later, you can adapt to other technologies based on the business requirement. So in that way, if you see, you need to have some good technology trends for yourself to see where exactly the technology is trending and whether your aspirations or a passion about certain technologies are in sync with that. So it is a good way where in which obviously you can make use of this Gartner hype curve or even a simple Stack Overflow, or and better would be this TOB programming community index for the programming languages. These kind of trends you can keep getting updated from a technology point of view. Yes, now comes the very kind of important topic, which I would, yes, I did get these things from what Dr. Manjunath Hebbar also, who had been here in Bosch for this uh, Catalyst program, the leadership program. So he had been very influential in bringing these kind of perspective to this professional competency. He told something like this, like breadth of experience and depth of knowledge, right? He brings some aspect to that. Similarly to those aspect, we do have something like this T model. It almost try to relate what he was trying to make. Here from this angle, if you see what we call it as T model of a competency, or sometimes it is also called as comb model or a broken comb model because it appears to be like a comb, which means to say there has to be a breadth in a competency, and this can be typically a technical competency or even any other professional competencies, and there has to be a depth. The depth you can measure according to your org level. And in Bosch, we have something called L1 to L4, where in which, simply put, L1 is something we are basic in that area. L2 is probably I know some uh, stuffs about that, but I need a good mentor or a guide to really work along with that person and try to deliver the final output. But the L3 is more like independent working. So I can independently work on those things given an opportunity. L4 is other than independently working, I can even contribute for trying to talk about that or even train or coach about those things for others. That's how a level can be kind of differentiated. Now it's up to you to how you kind of build your own team model. And of course, when you try to see over here, for example, if I try to claim myself, because all these competencies, most of the times it will be more like claiming systems. It's challenging between the claim versus the actual competency you have, unless and until it is evaluated in a proper holistic way. Otherwise, what do we mean? What do I mean by this? That I have a level of L4 that I can even train others in this area is in this test measure and control systems. I have a level of L4, but it doesn't mean that I can know how the workings of fuel injectors or even this accelerator pedal or whatever sensors in that depth. What I mean is, while implementing this test measurement and control systems, I'd use these techniques, tools, technologies, or learnings in these areas. And specifically, me coming from the Bosch software company and specifically to the manufacturing industries, I had done these kind of test measurement and control systems for these kind of products, the actual product manufacturing areas. Similarly, for example, a typical programming depth also can be seen. Again, same thing. Where did I apply? I'm trying to emphasize here that my LabVIEW programming competency is very good, and I had used in this implementing a SCADA system and communication protocols or algorithms, something like this. It doesn't mean that I have a very good hold on algorithms, but it do mean that, okay, I have a good programming language experience. So you'll have to see how do you want to convey using this T model to others. And basically, when you try to kind of bring in your own personal T model, you will have to be very careful that how do you balance between the business requirement and your own passion. Yeah, that is where I'll try to map certain engineering fundamentals. This is where I want to bring in some aspect that, okay, what you learn in the industry and what we kind of really implement in the specifically in the software industry, how it is correlated. Sometimes when I try to bring in the perspective of test measurement and control system, obviously me being from this electronics and communication, I might have to be very good at this test measurement and control system, specifically the sensors, the actuators, the transfer function, the calculus. If not the real depth of the calculus, I need to understand what do I mean by differentiation and integration. How do I apply that? For simple example, if I want to say that I had used this kind of integration or some kind of let's say differentiation in this MEMS-based solution, that is your micro electromechanical sensors, the small sensor chips which can actually sense accelerometer acceleration, and also it has this gyroscope and magnetometer. If I get this acceleration as an output, if I try to integrate that, I would get a velocity. If I further integrate that one, I'll get a distance. This is a theory, right? I would have literally applied that one at least to prove that the POC works in this sensor. Of course, we do need many other things. Simple integration would not suffice here. We do need to have other calibration and then estimation techniques and filtering techniques. But try to relate your education from your what you might have read from a mathematics point of view. This is where we apply from an industry. Similarly, if you see certain other transducers, if you are coming from this instrumentation area of the engineering, then obviously you would have seen that, okay, the accelerometer is nothing but a potentiometer. The speed sensor is nothing but a changing magnetic field concept, what you have read. So obviously I would have kind of even relate this pressure sensor to a strain gauge, injector to spring stiffness. So what you read as spring stiffness, basically we use those concept to actually develop injectors. And when we try to kind of test these injectors, I might have used some kind of LabVIEW programming and try to acquire that injector output through some kind of signals. I would have analyzed whether the injection is properly handling is happening. And also I would present a report or display telling that, okay, this is the opening pressure or whatever it is according to the product specification. So while this happens, you can try to see that what you try to learn from your engineering aspect, it is also relevant from where you kind of apply to the end software. Similarly, if you try to see the data processing and analytics point of view, you would have seen that curve fitting, correlations, all these are some of the mathematical, let's say, syllabus what you have in your engineering. But if I try to kind of relate that one, for example, we had done this vibration analysis. Obviously, the vibration analysis can be done in a various ways. One of the way we took from a fast Fourier transform, which means we applied FFT onto the signals wherein which we can get the natural frequency of that particular component, which can be multiple. For example, if I try to say it's a machine or a pump or whatever it is, a machine or a pump will be having many subcomponents. So we'll have to put a sensor onto that and try to see what's its natural frequency. Now, when you try to measure these things, what we call a natural frequency is a signature of a component. Now that particular thing, we have a standard signature and we can kind of record. When you try to see that, okay, in the normal operations, this signal is again coming. Now you can actually correlate that this kind of signals are again coming, and it might be a problem that, okay, this particular component or a subcomponent of the main component is having some problem. So kind of this fast Fourier transform has been used in vibration analysis. Similarly, your computer science perspective, if you see operating system, networking and all, obviously you would have used in some communication protocols or even other protocols like this MQTT and all. Obviously, you would have even touched upon this kind of data structure and algorithms, vector and raster graphics and all from an animation point of view. So where we can apply in the 2D shop floor mapping and a 3D animation, or what you kind of see from an Autodesk or Inventor kind of tools, we kind of may have made some kind of a lower version of it just to bring some business logic to that. So in this way, if you see from a professional competencies, if you are from a computer science background or an electronics background, information technology, there can be seen that, okay, you start off with your own, let's say, uh, 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 knowledge wherein which you are already gaining, you will apply those things in the your actual project in your industries. But over the period of time, when you gain experience, you will be seeing that you might have to kind of interrelate certain other areas also. That is where the context of solutions, or what we call it as systems, come into picture, which means if I want to give some example, this would be a best fit, at least from a manufacturing point of view. In a simple production machine, if this is a use case, typically this is my final output. Yeah, production machine I need to do. It's not a product. I might use a production machine to do a product. Being now the use case that it is, I'm focusing on a production machine, this is how the ecosystem would look like. But if my intention was a product itself, then it would not be in this area of the frontline operation of the factory ecosystem. It might be in this other business operation and manufacturing, where in which I might have to more focus on the engineering or the R&D part of developing a product itself. But now the use case is more about the production machine. Now in this case, my end goal is to do a production machine. I do have a factory ecosystem like this frontline operations, which focuses on all these production equipment to be developed, and also it could be manual assembly, all those things. When we, as a software company, or even let's say a manufacturing company as a whole, what we kind of see here is we do have mechatronic systems over there. I will not try to classify them as pure mechanical system. I would bring in mechatronics because it has many aspects of electrical, electronics, and even computer science related to this from a mechatronic point of view. In a simple, even a simple shop floor machine can have these kind of things. Yeah. Of course, we can see that most of the mechatronic system or mechanical systems are kind of supported by the CAD models. And similarly, from an electrical system, wherein which if I want to kind of connect all these mechanical systems or sensors and actuators to an electrical panel, I would have to kind of design that one using certain tools like ePlan. Likewise, if I try to connect this electrical system to a software system, I might use many other tools and technologies like this modeling and kind of implement these kind of software, whether it is Windows based or Linux based or even a PLC based for that matter. So it depends on what is your actual production machine is supposed to do. There will be a multiple domains and technologies associated with this. The technology can be related to the PLC, or it can be a Windows or even a mobile app or a web app systems. While other systems are there from an ecosystem like lean manufacturing, that how a production machine can be efficiently be developed with lesser cost and try to have a lesser wastage on this from a production point of view. There are other value chain systems supporting these things, which means when we try to bring the mechatronics systems, some procurement have to be done, and logistics is involved, and then there is a commissioning also involved. So all these kind of interrelated activities would be there typically in the industry. Now, coming from an academic background, whether I am a mechanical person or a mechatronics or something like this, the best fit would be somewhere here. Similarly, from an electrical point of view or a pure electrical point of view, we would be coming from here. And of course, when we think from a software, we have multiple options. So from a solution angle, if you see, or from a system, when we call it as system is, okay, typically when we try to say something as a system is, as it involves people, process, tools, technologies, everything conceptualizes to a system. And you can see that there are people, process, technologies, tools, and all. So this is what typically an industry would look like, wherein which from a high level system, if you focus, you would literally try to see different engineering aspects associated to this. Yeah. So in that case, if I want to bring in next, let's say, a thought process to this, you could have seen that it's a very complex system. Then definitely there have to be some kind of categorizations and all. Who does what? That is where we focus on certain roles in industries. And of course, this is where the aspirations of any engineer, right from the fresher to wherever he will be focusing to a president or a manager in any part of industries he goes or he or she goes. Basically, we focus on these kind of different roles. Of course, there are many roles, and it is typical. It can change industry to industry, but more or less, it is this is what it is for manufacturing. We do have this kind of plant managers and also associated with this R&D, HR, finance, sales, marketing people. And then we do have this production engineers, the process and control engineers. When we meant by process, it means to say in a manufacturing, we do have multiple processes. Examples. If you try to see from a starting, we do have something like this assembly itself. And likewise, you have multiple processes. Like simple example could be like painting process, welding process, tightening process, pressing process. These kind of multiple processes are there, and we do need a strong mechanical knowledge, experience based, or basically electromechanical knowledge experience based engineers who can think more from a product angle or from a machine point of view. Similarly, we do have this maintenance engineers who kind of maintain the machine or equipments. And then obviously we have this assembly line supervisor and operators. From an engineer point of view, you can see that the engineers best fit over here. Of course, we can also think of some line supervisors, but typically engineers fall under these areas. Similarly, from a software industry, we do have these kind of basically engineers. We call them as developers. From there, they go on to either become a manager if they are management oriented, or they do become a technical people like this architect and specialist. And then finally, they head towards this directors, either from an engineering point of view or a technical point of view. And obviously, we do have this vice presidents and presidents, whether we categorize them as CTOs or CEOs. So in this direction, if you try to see, these are all the typical roles in an industries. So when you have this kind of domain technology, engineering fundamentals, all these things, you do end up from basically from at least from a software point of view, from a developers to at least something like directors. And typically how it would look like would be something like this. From a career path, if you try to see, I just kind of given some rough way to bring in some aspect. Yes, whether you are a fresher or an intern, you will be for sure having a scope of being incubated as an associate engineer in any software industries. And of course, when you try to see, an intern may get an industry exposure. Fresher can have some kind of basic courses like Udemy and LinkedIn. This is where I try to emphasize on where you can kind of take some leverage of self-learning yourself, or even try to use an ecosystem of a corporate itself to go in this career ladder itself. Some may be aspected towards the self-learning, some may be towards these certifications. Yes, always there will be a challenge that claiming of competencies would be a definitely a challenge in industries. That is where sometimes we do prefer to have some kind of a good certifications. Yes, not like really from LinkedIn and Udemy, it is a good starting point, but at the same time, some internationally recognized certifications are also very much valid. So in that aspect, if you see a fresher or intern, when he or she try to be a software engineer, they would be getting a lot of, let's say, corporate ecosystem itself to have a good onboarding or orientation programs. Similarly, we will have something like either a corporate level or an on-job trainings itself. So that will further accelerate in them to become a senior engineer. There again, we will be having something like online, offline foundation courses and all. And then again, some professional and career guidance would be coming, wherein which this is where the typical, or let's say an important decision might be have to be taken from a senior engineering point of view, whether they step into a management direction or towards a technical direction. That's how either they would end up with a proper professional and career guidance to either become an associate manager or a technical lead. While we are in technical lead, it is better to have certain certifications like this internationally recognized IREB for requirement, UML for modeling techniques, the software modeling techniques, and this professional developers. Because how do I trade that? Okay, I'm a very good software developer who are actually trying to have all the design principles incorporated. But to take up the certain, let's say, certifications which will try to evaluate your software developer experience point of view. With these kind of certifications, basically we are requiring this technical lead to know certain platforms and tools, which means the programming languages, the IDEs, the operating system, all these things are very much important. Similarly, along with tools, like what we kind of told, like, okay, what kind of build tools we can have, what kind of scripting we can have for testing, and other tools for sure. So in that aspect, once From a technical lead or associate manager, we can further navigate towards the project manager or an architect. Either a project manager or architects, they will have a very good knowledge about the organization tools and methods. Each organization may have its own tools and methods. Simple example, we started off with this kind of DAR, design alternatives. For that, some tools techniques would be there. Similarly, for other requirement management, certain tools would be there, very much specific to the org level. So this is a common, let's say, the knowledge required for both project manager and architect. Specifically from a project manager, there are certain, for sure, certifications. Similarly, for an architect, the international software architect or a TOGAF based certifications is good to have so that they can really claim that they are good in the architectural aspect of it. And if I'm an architect, I should be more focused on technologies and methods. Yeah. From there, now to become an expert, or from project manager, if I want to become a senior manager, I need to kind of navigate a hard path. I'll have to choose from an at least a managerial aspect, either a program or product manager. Meaning, there might be a situation where in which I'll be only focusing on one or two projects. But if I want to handle multiple projects, I may have to become a program manager. But at the same time, I may choose not to become a program manager, but I want to work on certain product development. Then I'll have to focus on product management. For certain product or program management, there are a couple of certifications. Then you can kind of go towards the senior management path. Similarly, from architect, if an architect wants to become an expert, there are multiple, let's say, expertise required. Of course, there are different kind of technology, let's say the expertise, whether it is application technology and other two things are there, which is not relevant for now. Otherwise, we do have something like solution expertise also, which means I can try to bring in all the application technologies integrated and finally give a solution. So which means to say, I can either be a technology expert, I can either be an application expert, that is a pure software application expert, or I can actually have these application technology, data, business all together, bring into a context of a solution. So that will become a solution expert, or sometimes we call it them as system experts. So this is how you can have an aspect of solution or certain application technology architect. There are a couple of certifications like DRBFM. This is basically for the design review way, and also OCA is an international recognized open group architect certification. Mainly these people would be more focusing on domains and systems. Yeah. And then finally, they would end up to become an expert or a senior manager. These people will more focus on coaching, mentoring, and networking. This is more an experiential, which means all the certification doesn't more think about the knowledge aspect or the application of knowledge. It is also experiential. The review mechanism itself will be more on experiential. Going forward, certification would not be much of useful because you need more of a leadership, people process technology aspect to your career, and that is how you will be gaining forward to either become a engineering director or a technical director, where in which people will be focusing more on the business, like this efficiency, what we are talking about, and obviously the talent who can get the things done finally. So this is how typically a career path in a software industry would look like. Yeah. So if I want to summarize, basically there are some common skills or competencies required, and then specific skills you'll have to bring in the blend of these things. At the same time, software industries try to provide an horizontal service or products for many other markets or domain. For everything, you should have a strong engineering fundamental, specifically if you're in the technical aspect of it. And obviously, you need to have a soft skills, both from a technical and managerial aspect to it, because there's a foundation for any professional and career growth for sure. Then using this corporate system, basically where the corporate are more thinking about this, what we call it as the academia should be more like a ready to industry aspect of it. No, you will have to literally come and onboard in such a way that your skills can be utilized in such a way, and then it will move on to from improving the productivity and efficiency of a task itself. Because when you have this kind of Gen AI system or this AI based system wherein which you can actually automatically code, technically I should be more focusing on not keep on typing the code, but actually rather use these kind of tools and techniques to improve my productivity or efficiency. Yes, and finally, the continuous learning is a way forward for anything to be adapting towards this VUCA change. Yeah, this is what I want to just kind of summarize. So, thanks for Buoyancy for taking this initiative of having this industry connect. Special thanks to Mr. Dr. Manjunath Hebar who has initiated, and Chinmay and Sachi who are actually conducting these kind of initiatives. And I think this would actually improve lot many students and even industry in this case. Why? Because literally now I'm actually also trying to mentor some MTech interns and even trying to bring in certain other interns. The intention over here is when we get this engineering or MTech interns, when we get into this internship, basically it's not that okay they come and go. Basically we want to see whether the person can actually be onboarded to the industry. So it is like industry readiness is actually brought in this aspect. So in this way it's a good initiative that okay we are taking up from sharing certain knowledges, at least in a good, in a simple overview. This can actually bring in lot of idea or clarity to see which direction we can go forward, whether in a software or other non-software industries also. Thanks again. Yeah.
Hey, thank you, Kiran. I think your presentation was very well structured. I think you covered almost all the points which, from a student's perspective, would they would need to know. Particularly from outside, you don't really understand these things. So I think it's good that you brought this topic up of competencies because it is very hazy many times from the outside. So yeah, I think loved your presentation. Very nice. I think this career path, the diagram also is very good. Brings a lot of clarity in terms of people who are wanting to enter the industry, or even young professionals who are already part of industry, maybe starting out or with few years of experience. I think how they need to really channel their path. So
Yes.
I just want to know, I think you have covered a lot of things, but I would like to hear from you some top three things, given your experience, since you are also working with other MTech interns and other young professionals you are working with. What do you think are their key challenges that these guys need to work on, either as part of university programs or even if they are part of industry right now? Some three things that you are observing that are challenging for students, where you think that they need to possess these skills.
Yes. First of all, I would say from problem solving skills. Why? Because one thing, the major observation, if I want to say, is that generally we are kind of having that biased view of trying to work on always these kind of emerging technologies like this AI, ML,
Ah,
cloud, or something
correct.
like this. Yeah. Typically if you see here, and specifically actually this is my own team model of competency. Now I say
Mm-hmm.
that in my data science I
Mm.
am just in L2, which means I can simply do some trainings and POCs, because I do have a big department who is actually doing a lot of AI ML related activities. I don't want to invest my time onto that, but I do need to know from a domain point of view, because they don't have a domain knowledge. I will have a domain knowledge, but they have the
Mm.
technology knowledge of it. So if you now, from a university point of view or a student point of view, if I get stuck on these areas, basically I would be more focused on something like influencing, meaning somebody would have been influenced that okay, this is the way forward. That's
Mm.
a prospect I brought in, wherein which first you try to see where you are passionate about, what you really like from your engineering point of view. If you take
Mm.
an electronics and communication,
Mm.
you might, I mean, so if you see here, from an electronics and communication, from my background, I'm not being an embedded programmer here, but I'm
Right.
actually from an industry point of view. If you see, this is where you can bring in the aspect of uh, this perspective. From a
Mm.
production machine, if you see, I do
Right.
cover a lot of software. When the software has a problem, I'll have to pinpoint whether it is from an electrical system or a mechanical system.
Mechanical. Yeah. Yeah.
And
Right.
also, I need to know about the product also, which means whether the product is an accelerometer or whether it is a speed sensor. I need to know what is happening so that my software does right things, right? Now I'll
Mm.
have to pinpoint whether from a mechanic, of course, I might not be an mechatronics expert or an electrical expert there, but I can at least try to convey where is the problem. This problem solving skill is what is really required from a
Mm.
engineering aspect, wherein which just a theoretical knowledge is not good enough. Basically, you need to apply that one to a problem.
Mm.
Why? Because we always end up trying to bring a solution first. We don't understand the problem itself. So how do
Okay.
you bring in the aspect of problem to solution? Of course, you would have seen that in engineering, there is a course by now itself that design thinking aspect is there. This
Okay.
exactly focuses on that problem to how you can traverse from yourself from a problem space to solution space. But of course, that is more from a product development idea point of view. But the same thing can be applied even over here. So
Got
start
it.
focusing on the problem and then for the solution. So problem solving skill is one big thing.
Mm.
And then the next one I would be focusing on this for sure. Communication is very excellent, but the cooperation model have to be there from anybody, which means to say it cannot be that okay we are something more like individualistic in our own sense. We have to collaborate a lot. Why? Because when we try to bring about this productivity or this efficiency improvement, it's not possible that okay a one man army show kind of things would work. Whether I am in this kind of associate engineer just entering or even in this kind of senior manager, we highly have to have this collaboration so that we are not talking about something we are producing one simple solution, but it is a system together, right? A solution. Obviously,
Mm.
the collaboration is very important, and this skill or this kind of trying to be having a good cooperation mechanism is, or the mindset, yeah, that's the mindset we are talking about. It's very important. And finally, I would try to bring in the engineering fundamentals itself, which means when I try to start with this non-biased mode, no, that okay, I should not be thinking from a AI solution. Where
Right.
I was supposed to implement that AI solution, I should not be talking about algorithms, but I should
Mm.
be talking about what algorithm can solve what problem. Is it relevant? Because nowadays I would be seeing most of the times that okay, let's do these kind of algorithms, but we don't understand the requirement itself, right, properly. So
Mm.
in that aspect, engineering fundamentals is very much important so that given a problem from a business angle, you can
Mm.
bring in the aspect of whatever, let's say the other cooperation models we can get from, meaning I don't need to know everything, right?
Yes.
From the implementation point
Exactly.
of view, how
Right.
do I collaborate with others and then try to bring in my own engineering knowledge and try to emphasize where I'm stronger. To begin with, I might be strong from not from an experiential point of view. That is what I'm trying to say. If I'm
Mm.
coming out of an engineering university, I would think that I may be good in C program,
Right.
obviously, or maybe some C sharp program from a or a web program from a computer science background. But at the
Right.
same time, I'll be focusing on some of my own T model, right? It may
Correct.
not be from L2, L3, but at least some L1 and L2 should be sufficing. Now, in that aspect, if you try to bring in, how can I have this engineering fundamentals to the level what I claim is important? Because when we try to see really, if I try to want to evaluate a person to be L2, I see it is mostly L1. So these
Correct.
kind of better that certification will be one helpful way to
Mm.
kind of literally not claim yourself, but actually kind of get it evaluated from others. That
Mm.
was a good way. So basically, problem
Understood.
solving, cooperation, and the competency, that is the
Okay.
engineering fundamentals, is
Mm.
important.
Oh, I think very good. I think very fair. So guys who are watching this video, I think do try to create a team model. I think this is a fantastic idea. I think many times we don't really reflect back on really what competencies we have and what is the depth of competencies we actually possess. Unless, so as we are in the early stages of your career, so I think it is going to really help you guys to really develop your own framework or derive from this T model framework, which is relevant for you in terms of identifying the breadth and depth of competencies you guys have. I think it's a wonderful thing you can take back with from Kiran's talk today. So one other quick question on the career path that you showed. I get a sense from people that somehow in the technology spectrum and technology landscape in India, the technical career path is not so lucrative or not there, and everybody aspires to become a manager. I just want your perspective on how true is that, not just for Bosch, but from a industry perspective, you can comment.
Yeah. Uh, Yes, I might be having less expertise on talking on other industries. I for sure I can talk about Bosch for sure because obviously Bosch is like an ocean and it has multiple, like you saw, no mechanical, everything it has, and it also has multiple domains. So even in that way, I think it would be common for even others and limited knowledge on other industries also. Generally, the trend, what we see here is when we talk about something, the business is now focused on what we call it as more of a profit based, what we call it as non-linear growth. Yeah. And also they are more onto this kind of VUCA change. The trend is that what we see here is there is something efficiency and productivity improvement happening all across the industries, specifically in the software also, wherein which a strong engineering fundamental based, that is technically inclined aspect is emerging now. This is what I can see the trend. Yes, you are right from, let's say, the previous experience point of view, wherein which if I'm a manager, I'll be having a very good career path. For sure, I can be almost to a president level some point of time, be it a given good luck is also involved over there. But otherwise, technical is always they see at some point of time, let's say in we had a perception that we would get stuck in something like I being an expert, that's it, and no more further things would happen. I would not be connected much towards the industries or other industries and all. But the trend has been now happened that and obviously you could see in many cases there is a blurring between the actual management and the technical aspect, which that is where you can see that we have a lot of common skills and less of specific skills. So in that way, the same thing is applied even over here. In a sense to say, what I want to bring in an aspect of this certification, right? The OCA, Open Group Certified Architect point of view, an experience of a project management is also required to actually get certified in this one.
Oh, got it.
Similarly, if I want to bring in some kind of a product in this one, obviously the product have to have a lot of technical things. So which means there is a blurring of these kind of uh, competencies if I want to put in this direction. That way, the technical career path is also very much lucrative nowadays, which means it is kind of trending a lot for sure. That's what I want to bring in my experience here.
Yeah, fair point. I think I agree with you, Kiran, here. About I agree with you regarding the blurring of boundaries. I think hands-on leaders are very much sought after. Having depth in technology, particularly when you are part of a technology-centric business, having a deeper understanding of technology always helps. And I also agree with you that, I mean, you can look at many of the CEOs who are there of all well-known companies. I think they started off with
Yes.
strong technical backgrounds.
Yes. And
So,
if I want to interrupt, sorry for this,
yeah,
if I want to bring in what Dr. Heba's point of view, no, he made a very good point here is from a management point of view, you should have a very good breadth.
yes,
And of course, you need to have a lot of depths, but in your own way, which means it could be
correct,
even some could be more, some many things have to be fair enough
correct,
to understand in L1, L2. But at the
correct, correct.
same time, from a technical point of view, you need to have a very good depth, at least
Yes,
in certain things, and you
yeah,
still need to have certain breadths also, which means it's like trying to balance around
balance
what's
both.
your breadth and depth for sure.
Yeah. Fair point. I think, guys, I think once you reach that level, I think that insight will come when you are actually able to figure where your insight, where your trend and where your thought process is taking you, whether on the managerial side heavy or a technical side heavy. Either way, a great career awaits you guys. So I think we have run out of time now, Kiran, but thank you so much. I think you spent a decent amount of time explaining these parts. Very, very insightful. I'm thanking you. Very insightful talk. I think I'm sure it will be of great help to all the young budding guys who are wanting to join the industry. Thank you so much.
Yeah, happy to support and thanks for the initiative and opportunity. Thank you.
Thank you.